in this lesson, we're going to look at the difference between polynomials that have an even degree and polynomials that have an odd degree. So what we're going to do is take a look at three graphs to start off: f of x, g of x, and h of x. See the three right there that are on the screen right now, and they're on your paper. I actually have these all graphed on my calculator ahead of time just to save time on the video for you. So what I've done is we'll start with this actually in the y equals. See, I have them all typed in here, all the ones we're going to need. And I only have the one turned out. Well, I'll turn one of them on at a time. So I have x squared. See how it's highlighted? The equal sign is highlighted. That's something when you get your calculator. The equal sign highlighted means it will graph it. If you have things typed in without the equal sign highlighted, it won't graph it. So I have these turned off, and I have x squared turned on. So let's take a look at x squared right now. And there it is. There's a normal Zoom 6 regular window. And there's x squared. You should already know what x squared looks like. All right, so we're just going to sketch that. X squared does something like that. Okay, just a rough sketch. All right. Now let's do the 2x to the fourth one, 2x to the fourth. So I'm going to turn off the x squared and turn on the 2x to the fourth one. All right, and I'm going to graph that. And there it is. So that's the 2x to the fourth minus 7x squared plus 1. All right, so we're going to it's kind of like a W, right? Yeah, that was awful. Hopefully yours is better than mine. Let's let you take another look at it. Watch what I'm going to do. This work? I just cheated. There we go. There we go. All right. And negative 2x to the eighth. That's this guy here. Oops. Turn that on. I'm going to turn off the x to the fourth. And graph. And I'm going to cheat again. All right. I'll blow that up for you a little bit. Okay. Hopefully you could see that. I'm going to blow that out. I'm going to blow that one up in the middle of the screen for you so you could see it. All right. Just copy that down onto your paper in that third spot there. All right. Got it? So let's take a look at what is the degree. So we're going to do each of these. What is the degree? So what is the degree here? I'm going to move it up a little bit. Move everything up a little bit. So what is the degree on this first one here? Well, the degree is, the highest exponent, so the degree is 2. What is the degree here? The degree is 4. What is the degree here? The degree is 8. Is this an even or an odd degree? 2 is an even number, right? Even or odd? Even or odd. So what we're looking at here are 3 even degree polynomials. What is the end behavior? Okay, well, the end behavior for this one, notice how it goes up and up. This one, up, up. So infinity, 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 infinity. This one goes negative infinity, negative infinity, right? That's the end behavior. Okay, so the end behavior is as x approaches negative infinity, y approaches infinity, and then as x approaches infinity, y approaches infinity. So it's y approach infinity, y approach infinity. This one here, I can't fit it all. You're just gonna. So I'll do 2 lines. As x approaches negative infinity, it's the same thing. Y approaches infinity. As x approaches infinity, y approaches infinity. So it's infinity, 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 infinity. This one here is as x approaches negative infinity, y approaches negative infinity, and then as x approaches infinity, y approaches negative infinity. So negative infinity, negative infinity. What causes the end behavior of h of x to differ from the end behavior of fx and g of x? So why is the h of x one different from f of x and g of x? Well, I hope you notice that the negative in front of the, you should already know this, the negative in front of the leading coefficient, that makes it different. So the negative, so just put negative leading coefficient. Negative leading coefficient. All right, now sketch the graph of each of these functions. So we have x to the third, 2x to the fifth, and negative 2x to the ninth. So we're going to bring up those. So we want x to the third. Turn that one on. And I got to go down here and turn this one off. Oop, I didn't do it. There we go. So this is x to the third right here. There we go. Okay. So there's x to the third. I'll get the next one going while you are getting that one. Here's the one that's 2x to the fifth. And here is your negative 2x squared there. Or, I'm sorry, negative 2x to the ninth. All right. And there it is. Blow that one up a little bit for you. Here, I'll get, can you see it? I don't know if you can see it. There it is. I'll give you a chance. Pause the video, get it. And then we'll go back. Put it back where it goes. Okay, there we go. So, what is the degree? Well, we have a degree of 3, degree of 5, degree of 9. So notice how these are all odd degrees. Odd, odd, odd. Okay, odd degree. And look at the end behavior. Negative infinity, positive infinity. Negative infinity, positive infinity. Positive infinity, negative infinity. Again, the leading coefficient makes that change. So hopefully what you're seeing here is when you have an even degree, it either goes up, up, or down, down. And when you have an odd degree, it goes up, down, or down, up. Okay? And that the difference between those is just the leading coefficient. So a positive, it'll go negative infinity, positive infinity. All right. So what is the end behavior here? As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. So opposite, negative infinity, infinity. See that shows it's an odd. That's how you know you have an odd degree. You have an odd degree when the y infinities don't match. This is the same thing. So I'm not going to write it again. You write it again though on your paper. So what this thing, exact same thing. X, negative infinity, y, negative infinity, x, infinity, y, infinity. All right, and then this one's the opposite. Why? Because we have a negative, again, negative coefficient, leading coefficient. I know I didn't give you enough room here. Negative leading coefficient for p of x. All right, what is the end behavior? This one's going to be as x approaches negative infinity. Now the y approaches infinity. As we go to the left, the y is going to infinity. As x approaches infinity, y approaches negative infinity. All right, and again, the end behavior, that's just review. We've done that. We did that all last week. All right, so hopefully we're understanding. So even degree, you're going to either go up, up, or down, down. And I'm going to summarize that here for you. The next page just summarizes it. Even degree, right? Even degree with a positive coefficient, even degree with a negative coefficient. Here's your end behavior. Here's what the graphs look like. Odd degree with a positive coefficient. It's kind of like a cheat sheet here. Odd degree with a positive leading coefficient, you're going to have a graph that looks like this, negative infinity, infinity. And odd degree negative coefficient, you're going to have negative infinity, infinity. All right, actually those are backwards. That is wrong. Oh no, yeah, no, that's right. They wrote the positive first. They wrote the positive infinity first, then they wrote the negative infinity. All right, that's why. Yeah, so it's negative, positive. All right. And this example we're going to do in class because you have to type stuff in your calculator and you really need to show you how to do it. You actually have to do it. So no sense in doing the video. So I'll see you then.